Alright, salutations pre-calculus class. So we are continuing on with our video series on looking at transformations as part of our Algebra 2 review in pre-calculus. So in the last video we talked about the vertical shifting and horizontal shifting of a graph based on the parent function. So to just summarize what we saw in that video, when we add outside of the parent function, you see here vertical shift of f of x plus c. So we see that we're adding the constant outside of the function. When that value is a positive, that's going to make the graph move up. When that value is a negative, it's going to make the graph move down. Then you see with the horizontal shift that the opposite, which we observed, happens. We add inside the function, we're adding inside of the function, that we are going in the opposite direction. So we see that when it was a number greater than 0, we actually moved to the left that many number of units, and when it was a number less than 0, right that many units. So again, if you need a little refresher on that, please watch the previous video. And I also had put links there so that you can use the sliders like I had done in the video to make the same observations that we did. So moving on into this video, we're going to look at now stretching and compressing the graph. So we saw what happens adding and subtracting. Well, what happens when we multiply or divide? So we're going to flip over to our web browser where I have, again, the graphing calculator up so we can go ahead and observe what happens when we multiply or divide. Okay, so again, here I have my original parent function x squared. So for this video, I'm going to use the same two parent functions and also that weird graph that we had. But now this time we're going to look at what happens when we multiply or divide. So my first one that I'm going to look at is I'm going to multiply outside of the function. So I'm multiplying after the fact. So this is that a is our coefficient in the front. So right now a is set at 1. So the blue graph and the red graph are overlapping. So as we increase a, so as I make it more and more positive, meaning I'm making it bigger than 1, notice what's happening to the blue graph. So this time it's not shifting, but it's getting skinnier. So what we would describe this as is a vertical stretch. So this is, we are vertically stretching the graph. So imagine, if you can, that the coordinate grid is this huge sheet of rubber, and you are going to grab the top and the bottom of the y-axis. You're grabbing the y-axis from the top and the y-axis from the bottom. And on that sheet of rubber, you drew this red graph. If you were to start to pull on both ends, then what would happen to the graph is it would start to look skinnier and skinnier. We're stretching this sheet vertically, and it's going to make the graph look skinnier. Notice how the vertex isn't moving. So it's not that it's shifting up and it's making it look skinnier, it's that it's stretching. So all of the y values are stretching more and more. So the more I make a larger than 1, the more it's going to stretch. Now, if I go back to 1 for a second, now what happens if we make it less than 1? So now if I start making them fractional values, then we start to see that the graph is now going the other way. It's actually looking like we are not stretching, we are compressing. So, and that's exactly what starts to happen with the graph as I smush it here. And it happens pretty drastically. So you'll notice if I get to like 0.1, I'm going to try to get there. So a big difference. So instead of grabbing the top and the bottom and pulling your hands apart, imagine grabbing the top and the bottom and bring your hands together. So you're kind of pressing vertically the graph. So once it gets to 0, now notice what happens. It goes completely flat, which, if you think about it, makes sense because 0 times anything, the answer would be 0, hence the perfectly horizontal line. So I'm not going to talk about negatives. I'm just talking about what happens when we multiply by a non-negative number. The next video we'll talk about what happens if it does in fact become less than 0 and what effect that has. But we can see and summarize that when the coefficient is greater than 1, we are vertically stretching the graph. When the coefficient is less than 1, but greater than 0, then we are we're vertically compressing the graph. All right. Now let's look at what happens when we multiply inside the function. So if we think about what we just saw happen, again, we would think, okay, well, I'm going to multiply inside the graph. So it should kind of do the same thing, right? If it's bigger than 1, it should horizontally stretch. So because now we're going inside the function, we are changing the x value directly. So instead of grabbing the y-axis from the top and the bottom, we're going to grab the x-axis from the left and the right side. And we're going to pull or stretch that sheet. So if I were to grab the two sides, so think about what happened before, when I multiplied, okay, when I multiplied by a number bigger than 1, that I thought would make the graph bigger. So thinking, okay, I'm going to grab the two ends and I'm going to pull the graph. So it should make the graph, this parabola, like widen out. So I'm going to say it's going to horizontally stretch. So let's see what happens. It would help if I made it visible. Okay, so there we go. Now if I make b bigger than 1, what's going to happen? Okay, so now it's not, I'm grabbing the two ends, and it looks like as b gets bigger, it's actually becoming skinnier. So, it's doing, again, the opposite of what I thought it would have been doing. So we've seen that pattern before when we did the shifting, that when I was doing it inside of the function, it was actually going counter to what I thought it was going to be. It was doing the opposite. So lo and behold, with horizontal stretching and compressing, we're seeing that same kind of thing happen. So if b is bigger than 1, we're not horizontally stretching. I'm not grabbing the ends and pulling it. It's actually grabbing the ends and pushing it in, so like we're smushing it. So this is a horizontal compression. So when b is greater than 1, horizontally compressing the graph. When b is less than 1, that is where we start to see a horizontal stretch. Okay, so you see how it's stretching here. Now, I do want to point, which some people might have observed, it's like, well, changing these numbers here, isn't that kind of the same as what happened here? Yeah, but it's not exactly the same. So you see how if it was less, it's opening up. When it was less up here, it opens up. But is it doing it exactly the same? So I'm going to put it as 0.3 here. So you can see the difference between the two. So it's not the same. Notice here, 0.3 here versus 0.3 here. They're not the same. Are they going to have, however, like a similar effect? Like it causes the parabola to open up? Yes, but it's not doing it exactly the same. So we cannot say that A and B do exactly the same thing. They do similar things, but in their own way. Okay, so I just wanted to kind of point that out because some people kind of, they see this observation and are like, so why do I have to learn both letters if one kind of does what the other one does? Yeah, but sometimes it's easier to kind of do it the other way. All right, let's look at our second graph. So again, same thing here. So now I'm going back to my absolute value graph. So it shouldn't matter. Let me switch this to 1. So it shouldn't matter what our parent function is. The observation is that it's going to do the same behavior like we saw in the first example. So again, if a is bigger than 1, see a is outside of the function. That means we're going to do stuff vertically, happening after the function is done, doing something vertically. So it is what it is. If the number is bigger than 1, it should be vertically stretching. So am I stretching the graph? Yep, that's what I'm seeing. As A gets bigger, or bigger than 1, I see that the graph is getting stretched vertically. It's not a shift, it's getting stretched vertically. Now, if it's less than 1, I should be seeing that vertical compression. So yeah, I'm pushing it down, smushing it. Finally, by the time it gets to 0, it goes completely flat. So looks like the same exact behavior like I saw with the quadratic. Now let's go to the other one. So now we're inside the function with b. Again, I'm going to set this up at 1. So what do we expect? As it becomes greater than 1, remember, I would think, oh, it's greater than 1, so it should be stretching horizontally. No, remember that once we're inside the function, that typical behavior of it's going to actually do the opposite, what I would expect it to do. So I'm stretching it horizontally, which means really should be compressing horizontally. So if I can make it bigger than 1, this V should be coming in. And yep, that's exactly what we see. As B gets bigger than 1, we are compressing horizontally. If B is less than 1, then we are stretching horizontally, grabbing the ends of the graph and pulling. So grabbing the left and right ends, I should say, of the graph. All right, so one more kind of visual to hammer this home. Let's go and look at our weird graph here. So this is the same weird graph that I showed you in the last video with our shifting. This time we are stretching or compressing. So first we're asked, what effect does A have on the function g of x? So we see A is happening outside the function. So if I make A bigger, this should be what? Vertically stretching should have been your response. Confirm that and see, yeah, it's pulling. So you see how the low end is getting pulled lower, the high ends are getting pulled higher. The more I do it, it's stretching. And notice that if it's at 0, notice where it was originally at 0, these points here, those guys never move, right? Because we're stretching, we're not shifting, we're stretching. Pull it, it stays right. Now, if it's less than 1, then we should be seeing what? A vertical compression. That's what we're seeing, right? It's like I'm grabbing the top and the bottom, smushing it down, I'm flattening the graph, and sure enough, what happens when we get to 0? No matter how ugly the graph was, it goes flat. Okay, so again, greater than 1, vertically stretching, less than 1, but still greater than 0, we are flattening, vertical compression. All right, now what happens with B? What effect does B have on the function? So now we're talking horizontally. If B is greater than 1, you would expect what? So horizontal compression was what you should have said. So we're going to see, yep, a horizontal compression. So you can you can see it a little bit better with this weird graph of, yeah, I'm grabbing the sides and I see kind of like that smush, like I'm grabbing it from the sides and like crushing it in. So that's a horizontal compression. Now, if it's less than 1, but greater than 0, then we're seeing the opposite. It's a horizontal stretch. So we're pulling it from the sides until finally it flattens out. Like kind of like getting a spring and pulling the spring out till it just turns into a flat wire, like so. So hopefully this kind of clears up the stretching and compressing. I will be putting links up to all 3 of these explorations so you can play around with it yourself if you're still having trouble figuring it out.